I'm going to log into this Linux system as root. Let's go ahead and look at the Pam configuration for login. Here you can see that the auth interface of the Pam_secure TTY module is being used. I'm going to run the W command, which will show what device I'm logged in as. Okay, I'm on TTY1. Now let's look at the etc secure TTY file. Here you can see a list of devices that root is allowed to log into. You can see that TTY1 is listed, and that's what I'm logged into right now. I'm going to remove TTY1 and attempt to log in again. Remove that, write the file, close out, I'll log in as root. And I supplied the root password correctly. I'll do it again. And sure enough, it's not letting me log into the system. So TTY1 represents the first virtual console on a Linux machine. To get to the second virtual console, you type Control-Alt-F2. To get to the third, you type Control-Alt-F3, and so on. So I'm going to switch to the second virtual console right now by typing Control-Alt-F2. Now I should be able to log in as root because TTY2, the second virtual console, is in the etc secure TTY file. Let me try that out. Log in as root. I get access. I run the W command, and sure enough, I'm on TTY2. And TTY2 is indeed in the etc secure TTY file. I'm going to empty the etc secure TTY file. I can do this by a couple different ways. I'll just edit it and just delete all the lines in it and write it. So let me look at that file. Sure enough, nothing's in there. So now when I go to log into root, I should not be allowed. Again, I can't log in as root on this TTY because it's not listed in the secure TTY file. I'll go ahead and log in as myself on my normal user account. And sure enough, that works. So again, the etc secure TTY file controls root logins, but not normal account logins. So if you want to prevent direct root logins, create an empty secure TTY file. For this demo, I'm just going to go ahead and use the root account. First, let's run vi sudo. You can see that it starts an editor. In this case, it's vi. Let me go ahead and exit out of that. And you can specify the editor that you want to use by setting the editor environment variable. I'll go ahead and do that for mine. Set it to nano, and then run vi sudo again. Now you can see that the nano editor was started. I'm going to go ahead and switch back to vi since I'm more comfortable with that editor. Exit out of there. Editor equals vi. Run vi sudo yet again. One big advantage to using vi sudo instead of directly editing the file is that it performs syntax checking. I'm just going to put some invalid data here at the top of the file and then go ahead and save that file like I'm going to write and quit and exit this file. So as you can see, vi sudo detected an error and it asks you what you want to do next. I'm just going to hit the enter key right here to show the options. So at this point, you can either edit the file again, you can abandon your changes, or you can force save them. Now, don't do that because you don't want an invalid sudoers configuration. So I'm going to go ahead and edit the file again, and I will take out this bad data that I put in there. When I exit this time, there's no error, so the syntax is correct for that file. Let me fire this up one last time here. Now let's create a specification for a user named Bob. I'll just put this at the bottom of the file. And let's allow Bob to run the user bin yum command as the root user on all systems. And we'll go ahead and exit out of sudo here. And then so let's look at what Bob is allowed to run. I'll clear the screen and run sudo-l, and I'll specify Bob with a -U, what user's configuration I want to list. And there it shows that Bob can run the user bin yum command. I can also do -L, which more or less gives more verbose output. We'll do that here for Bob. And then it just puts it in a slightly different format, and it gives a little bit more information here. So now I'm going to go ahead and switch to the Bob account. And if I was Bob and logged into this system, I could run sudo-l as myself, and it will show me what I can do. I'll enter my password there. And again, you can see that Bob is allowed to run the yum command. So let's install some software as Bob, since that's what the yum command allows us to do. I'll run yum install and install this program called dstat, which I kind of like to monitor system activities. So it's downloading and installing, and so that command got executed as the root user. I'll go ahead and exit out of here. Let's create a file in etc sudoers.d. So to do this, I'll use vi sudo-f and specify sudoers. Now let's allow Bob to run the whoami command as anyone on the system. Now you can see Bob can run yum as root and whoami as anyone. So we'll switch to Bob's account. When Bob runs whoami, it says he's Bob. So let's use sudo with the dash lowercase u means run the following command as this user. And I'm going to do that with the user Jason. So now when I execute that command, whoami, it says you're Jason. All right, let's do this again, and let's run a command as the Apache user. And again, the whoami command returns the effective user, which is Apache, because we use sudo to effectively execute the command as the Apache user. So even though this may be a bit of a contrived example, the point is that you can give permissions to one user to run commands as another user and tightly control that access. Also, there's a clear audit trail. This system is configured to log sudo messages into var log secure. Let's look at that file real quick. You can see exactly what user ran what command, and it even tells you what directory they were in when they executed that command.